Alright, and to get us started, we'd like a reader for the first two paragraphs. So let's have.
Sir, can I go?
Yes, you can go.
Some of the data you put into a computer will be needed right away for processing, while other data may not be needed for periods of time. Therefore, different methods of storage are appropriate for different uses. The main purpose of the CPU is to process instructions as quickly as possible. Main memory is located directly on the computer's main circuit board so that data can travel quickly to and from the CPU to be processed.
Good, thank you. That's okay, Rizwan. Um, so your computer needs data in order for it to function, in order for it to operate. So basically, your computer is made up of hardware, mouse, keyboard, CPU, and so on. But if you just have those hardware, mouse, keyboard, CPU, and you don't have data, you don't have software, then it basically makes no sense. What are you doing with the computer? What are you doing with just the hardware? You need data because that is why you have the hardware to process that data. Now, there are some data that you would need right away. So you need to access that data quickly. But then there are other datas that we do not need quickly, that it may take a long period of time for us to be able to use it. So, for example, say you created an assignment, social studies, and you created an assignment for social studies and you submitted that assignment. So you're finished with that assignment. That there is data on your computer. But you're not going to use back that assignment, so you store it on your computer or you store it on a flash drive somewhere. Now, maybe sometime in the future, when someone you know is in the same class, is doing the same assignment, you might share that work with that person. So that's data you would keep for a long time, but you don't need it right away. Now, there's some data that you would need right away. In order, those kind of data are data that the computer needs to function. That it can either be the operating system or some kind of software. It needs those data to function right away. But also, if we take back the example of the assignment, if you were to start working on that assignment, then that data on the assignment would be needed right away. So where, depending on how, how do I phrase this? Depending on how readily you need the data, how urgent the need for that data is, that will determine the data's location, basically in the computer. So the next paragraph speaks of the CPU. Well, the CPU is like the main person in the computer, and it is used to process information, process data. So to process instructions as quickly as possible. Now, I would have given you a homework to draw a motherboard, and the motherboard can also be referred to as the main circuit board. And on that board now is where you will find the main memory and the CPU. So in this,
Excuse me, sir. Tanika Wallace is having problems. Every time she logs in, she keeps jumping out, and she told me to just tell you that.
okay, thank you. So in this image here, this green stick that you're seeing here, that is the memory. Now there's different sizes depending on the kind of computer. This is a desktop kind of memory, so it's bigger compared to a laptop's memory, and it would plug directly into the computer to the motherboard. And if you look back at your homework that you would have drawn of the diagram, you would see that the CPU and the memory are both on the motherboard. Now, it says here that the main memory is located directly on the computer's main circuit board so that data can travel quickly to and from the CPU to be processed. So, alright, let's read out the two other paragraphs before I give you another diagram. Akila, can you read for us from main memory to features the next two paragraphs?
Okay, sir. Main memory is located directly on the computer's main circuit board, so that data can travel quickly to and from the CPU to be processed. Data stored at a specific memory location called an address can have its address contents accessed to be read from, written to, or processed. The largest amount of data which can be moved together to be processed is called a word. There are different types of computer memory. Let us look at some examples of computer memory and their features.
Good. So, there are a few terms here that you should remember, so let's go through it part by part. Now, the main memory is located on the main circuit board so that data can travel quickly. So let me give you that diagram now. So, let me see. If you are, so I'm drawing a motherboard. So this is like the homework you would have drawn. And this here is the CPU. And this here would be the memory. Now, on your connected to the motherboard, you would have maybe a hard drive. So this here is your hard drive. And what happens is that the CPU, this chip here, it needs data in order to process, in order to do the processing, in order to carry out the instructions. So most of the time, all of the data are on your hard drive. If you just have a hard drive installed, all of the data is on the hard drive. But the thing is, the hard drive is a slow device. So the time it's going to take to send that data to the CPU is longer than it would take for data to go from memory to CPU. So that's something you should remember. It takes longer for data to go from the hard drive to the CPU, and it's faster to go from memory to CPU. And that is why we have a memory in the computer, so that instead of the data going directly to the CPU, what the system does now is to send that data to memory, and from memory it sends that data to the CPU. So that way now the memory can pull the necessary information, necessary data that it needs from the hard drive, from the flash drive, any storage device, and keep it inside of memory, so that whenever the CPU wants to process that data, to process that instructions, it gets it quickly, because the CPU can process more information than it can receive. It processes faster than it can receive the data. So by time the CPU, if the CPU is sending, say for example, maybe a song, by time the the memory would have sent that full song to the CPU. The CPU would have already processed most of that song already, so that by the time the end of that song reaches the CPU, it has practically been processed already. So the CPU processes faster than data can be sent to it. That is why we need the main memory, or the primary memory, or memory, so that we can send data quickly to the CPU. Now, a term that you should remember is the term address. So if you look on the right here, this image with this green stick, that is the memory. So imagine now that this is the memory, and what happens is that on the memory has chips that store the information, and wherever that information is stored is called an address. So just say, for example, address A, address B, address C. So what happens now is that the CPU is going to store information at address A, you're going to store information at address B, and when the CPU needs back that information, it's going to look at memory and say, oh, I stored this information at address A, so that's the information I want. I store this information at C, so that is the information I want. So that is the address. And basically, like how we have a lot address to know where we live, it's similar to the address on your memory, so that the CPU knows where to store the information and where to retrieve back that information. Now, another term that you need to remember is the term word. Word refers to the largest amount of data which can be moved together to be processed. So basically, move together at the same time. How much data can be sent at the same time to be processed? So we're going to be looking at how this data is measured later on. But just know that it's the largest amount of data that we can send to be processed. So now there are different types of memory, so we're going to be looking at the types of memory. So this is a lot of new information here about memory, about how memory works and so on. Is there any questions so far? Anything you guys didn't understand?
No,
No,
sir.
sir.
No, sir.
Okay, let's move on. So we'll be looking at the types of memory. Now there are basically three types that we'll be looking at. The first one is random access memory. We call it RAM. Second is read-only memory. We say ROM. And the last one is hybrid memory. So let's have a reader for random access memory. Can you read for us? Durendra? Okay then. Jaim. Jaim. Naishal, can you read?
Yes, sir. Random access memory, RAM. Inside a computer, you will find one or more memory chips called RAM. These hold the temporary operating instruments. for the computer. It's programs and data. This is a place where the CPU receives the instructions and data it needs to do its job. The advantage of RAM is that the computer can access data held in RAM almost immediately. The major or disadvantage is that RAM is vo- volatile. All
Good.
data held in RAM is lost when a computer is turned off or malfunctions. This is why we need it to use other media to store our data. A computer program and operating system have become more complex. The size of RAM has increased.
Good. And then it ended with, alright, we'll come to that just now. So, inside of your computer, you will find chips called RAM chips. Now, RAM temporarily holds data. So that's something that you need to remember about RAM. It holds the data temporarily. So, but because it is faster than other storage, because it is faster than your hard drive, it is faster than your flash drive, we use RAM because it can get the instructions to the CPU almost immediately. That is why we use RAM. Because as I mentioned, CPU processes information very quickly, processes data very quickly. So we need something that sends that data very quickly also. Now the disadvantage of RAM is that it is volatile. So what the word volatile means is that when the computer is turned off, or basically when you lose electricity, anything that you have in RAM is gone. It has disappeared. It's no longer there. So that is why we need other storage devices like our hard drive, our flash drive, CD drive, and so on. Those are non-volatile devices that store the information and they do not need electricity to store that information. Now most computers they would come to with 2 to 8 gigabytes of RAM. Later on we're gonna look at what is GB stands for, but it stands for gigabyte. We'll look at that more. But the standard right now is about 2 to 4. I think right now, I think this is a bit old, but the standard should be right now about 4 to 8. That should be the standard because 2 gigabytes is no longer enough to run a computer effectively. Because what happens is that if you go back to the diagram, your operating system, which runs your computer, as we would have looked at for operating system, it runs the computer. And what happens is that that operating system needs to also be loaded into RAM. So the operating system is on your hard drive because it needs to be stored permanently. But in order to run your computer, it needs to be pulled also into memory. So if your memory is not large enough, it will not be able to function as effectively. For those of you who know about computers, this here is called a task manager. You get it by right clicking on the taskbar at the bottom here, task manager. And if you go to performance and you click on memory, it tells you how much memory your computer has and how much is being used. Currently mine has about 12 gigabytes and I'm using about 5.1. Now if this is filled up, what happens is that your computer starts to move slowly. Your computer starts to freeze because the CPU, the system, cannot access that data as quickly as possible. So that is why on your computer you need as much memory as you can get so that all that information can be stored inside of RAM so that your computer can run smoothly. But the main thing to remember is that RAM is fast, it can send the information quickly, it is volatile, that is the disadvantage, meaning that it loses the data when it loses electricity. So let's look at the other kind of memory. RAM. Let's have Shalon, can you read for us?
Yes, sir. When a computer is made, basic input or output instructions are put on ROM, read-only memory chips. These instructions can be read but not changed, non-volatile, and are available every time the computer is switched on.
Good.
Hybrid, sorry,
Good. So we have here another kind of memory called read-only memory. So it's just as the term here says. Basically, when the company sets up this memory, they store the information on it, but when it's being used, it is only being used to read information off of it. So it stores information called basic input output instructions. Basically, it's a set of instructions that your computer follows when it starts up. So when you press that power button on your computer, it follows some instructions inside of this ROM chip in order to start up the computer. Now, notice the word here, non-volatile. So this is the opposite to RAM, which loses its data when it loses power. RAM keeps the data without needing any power. So it is always available when the computer is on. Now let's look at hybrid memory. Tyra, can you read for us?
yes, sir. Hybrid memory. Recently, as memory technology develops, the line between RAM and ROM has been blurred. Now, several types of memory combine features of both. These devices do not belong to either group. They are called hybrid memory devices. Hybrid memories can be read and written as desired, like RAM, but maintain their contents with electrical power just like ROM. Flash memory is a variation of a RAM device that is typically used to store code.
Good. So the hybrid is basically a combination of RAM and ROM. So with RAM, we can read and write information. If you remember those terms, I would have explained it in a previous class. When you are writing information, it means you're putting information on something. And when you are reading, it means you are taking it off. So for RAM, you can read and write information or data. But ROM, yes, you can write, but it's only a one-time write by the company. And after that, you could only read. RAM loses its data without power. ROM keeps its data even if it doesn't have power. So combines all of those features, hybrid memory, so that you have both of those situations. You can have read and write for hybrid memory, and you can have the data remain even without electricity. Now, flash memory is a variation. So, flash memory can be like your micro SD card that you have in your phone, or even your flash drive. They all use flash memory to store that information, allowing you to read and write information. So, those are the three types of memory. Any questions on the three types of memory? You guys understand?
Yes, sir.
Yes, sir.
Anyone with any questions?
No, sir.
No, sir.
Okay, so let's go on to how data is represented. So this part here, I really need you guys to focus. It's almost like maths. Actually, it is maths because everyone should have learned the binary system by now. You guys know what the binary system is, right?
Sir, I know if it's me alone, but I do not know what's a binary system.
Base 2 system.
Um,
This taught us about binary system, I think, but I can't remember completely.
we had done something on binary operations. I think it was.
Yeah, that is basically the base 2. Like how we have base 2, base 5, base 10.
Oh, yeah, 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 yeah.
Yeah,
So,
yeah, yeah, sir.
Yes,
Now I
sir.
get it, gist.
yeah, binary is base 2 basically. So once you remember that, you should understand binary. So let's get into it now. The first paragraph. Jamal, can you read for us? Jamal? Okay then. Grace.
Yes, sir. Everything that the computer does involves functioning on and off of different combinations of microelectronic switches called transistors or bistable devices. The on and off states of the transistors are used to represent the zeros and ones that make up the binary number system. These zeros and ones are known as bits, binary digits. A bit is a chunk of information, piece of data that a computer can work with, either binary 0 or binary 1. The more bits a processor can use, the faster it can compute working time, and the more memory it can access easily. When you use a computer, millions of switches are continually being switched on or off by electric currents.
Good. Now, the first part is a bit technical. So, for those of you who are doing, who might do physics later on, or I think electech, you will learn about transistors. And the transistors basically have two states. They're either on or they're off. And in binary, there's also two states, a 1 or a 0. So, that on and off state in the transistor is represented by this 0 and 1 in the binary system. So, that combination is basically the data inside the computer, and the CPU processes the information as binary. So all that we're seeing here on the screen is actually binary codes, bits of zeros and one. The computer sees it, but we cannot see it. But that is what the computer is processing all the time. So the zeros and ones, they are known as bits. A shortened word, I forgot what we call the shortened words. A coined word. Yeah, I think that's the term. A coined word of binary digits is called a bit, and a bit is the smallest chunk of information or piece of data that the computer can work with. So it's the smallest piece of data. A bit can either refer to the 0 or to the 1 in the binary system. Alright, so let's have Sajid, can you read the last paragraph for us?
Sir, that will be which one?
A popular all the way to the 10 times.
Okay.
Up to here.
A popular range of processors is the i5 or i7 series, produced by Intel. The chip shown in figure 1.17 is made up of over 27 million tiny switches or transistors mounted on a slice of silicon. Computer disk.
Hold on. Oh, you gotta start from the bottom here.
Sir, I can't see it. Oh. If you think of all the programs on a computer, plus all the files that are saved, you can see that on each
Right up here.
computer disk there are millions of bits. Computer memory and storage size is therefore given in bytes, or 8 bits make 1 byte. Kilobytes or KB, megabytes or MB, gigabytes or GB, or terabytes TB. Kilo normally means 1,000 or 10 to the third power. However, 1 kilobyte is 1,024 bytes. This is because computers count by twos or binary, and powers of 2 are not in tens like humans. Therefore, 1,024 is 2 times 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 2. That is 2 multiplied by itself 10 times.
Very good.
Table.
That's it.
Okay, sir.
Right. So the first paragraph here is saying that on the common processor, the Intel i5 and i7, they have about 27 million tiny switches. So those transistors we talked about above here, which have that on and off state. So
Sir, I cannot hear you.
yeah, I'm no longer speaking. Just give me a minute. Okay, I'll just go with that explanation for now. The CPU is made up of these tiny switches called the transistors, and basically the more transistors, the more work it can do. So one example is the Intel i5 and i7. They have about 27 million of these transistors, and even today we have transistors, not transistors, CPUs with many more millions of transistors inside of them. Now this here is how the computer stores your information. So as we would have said over here, the smallest piece of data is called a bit, and a bit can refer to either a 1 or a 0. Now, when you have 8 bits, you now have a byte. So, in binary, there's only two states. Base 2 system, there's only two states, a 0 or a 1. So if we have 0, 0, 1, 0, 0, 1, 0, 1, that's binary. We have 8 bits, and that would give you 1 byte. So these 8 bits here refer to as 1 byte. 4 bits, so this 4 here is referred to as a nibble. So you can imagine it as something like if you're eating, 1 is a bit, then if you take 4, it's a nibble, and if you take 8, it's a byte. Now, if you look at the table below here, 1,000 byte is referred to as a kilobyte. Kilo refers to 1,000. So basically saying kilobytes, that is 1,000 bytes. But it is not exactly 1,000 because of the base 2 system. So let's see how good you guys are with maths. 1024 is 2 to multiply by all these 2's 10 times. So 2 times 2 is how much?
4.
4.
Who said 2?
2 to 4.
So 4 times 2
8.
8.
are 6.
16.
2 times 8,
16.
16.
good. 2 times 16,
Or 2.
32.
32.
good. 2 times 32,
64.
64.
good. 2 times 64,
108.
128.
108.
128.
128. 128.
128. 128 times 2,
256.
very
56.
good. 256,
512.
512,
And 1,024.
1024.
good.
4.
So you see how we arrived at the 1024
Yes, sir.
because
Yes, sir.
because we're using the binary system, not the decimal system, not the base 10. That is why 1,000 is actually 1024. Now, so you have here how much it is a power of. So 2 to the 10 refers to a kilobyte. 2 to the 20 refers to a megabyte. 2 to the 30 a gigabyte, and so on. So they're basically like they're going up by another 1,000. So if we have 1 byte here, this is a byte, and if we add 1,000 to it, just imagine it's 1024. That give you kilobytes. Now, if you multiply it by another 1,000, which is basically like adding 3 more zeros, so they're gonna be, let me put a comma here, comma here, comma here. That's gonna be a megabyte. So that's an easy way for you to remember it. Basically, like you add in three more zeros. So a million is actually a megabyte. Now, if you add three more zeros again, basically multiplying this 1 million by 1,000 again, as shown here, um, as shown here, 1024 by 1024 by 1024, you will get 1 gigabyte. So that's just as if you, which is going to be a billion, it's just as if you added on three more zeros, and that can give you your gigabytes. So that's how basically data is measured on your computer. We have a bit, which is the smallest, a 0 or 1. When you group 4 of it, you get a nibble. 8 bit gives you a byte. If you group 1024 of those bytes, you get a kilobyte. 1,024,000 of the bytes is a megabyte, and 1,024,000,000 of those bytes is called a gigabyte. And calculation basically goes on like that. So we, if you multiply 1024 by 1024 megabytes, you get a terabyte and so on. And there's larger sizes. So what you can do for homework is write down what are the other sizes and how you calculate what is beyond 1 terabyte and so on. So today was a relatively short class. So this homework here will be on your classroom once again. Please ensure you do your homework on time so that you don't get any deduction in your marks. Some persons still haven't submitted last week or the previous week, so they basically have no score. I don't know what's happening with them. Right. So, is there any question on this binary part that you guys didn't get? Anyone?
No, sir.
Alright then. So, if you guys don't have any questions, this has brought us to the end of today's class. I'll be here if you guys have any questions up to the normal usual time we're supposed to end. But if
Sir,
you want
I would
to
like to
leave,
ask a question.
yes.
Sir, even if you have the IT book, do you have to write back all the notes inside your notebooks? If you
Yes,
have
you
the
do.
textbook, your own personal textbook?
Yes.
Okay,
IT
sir.
is a new subject to you, and reading would not help you only. Writing helps with memory retention. So for now, for IT in third form, you'll be writing so that you remember the basic stuff. When you get to fourth form and fifth form, that is a different story.
Okay, sir.
Sir, I have a question.
Yes, Rizwan.
Sir, let's say you bought a new computer and it's getting older and older. Why does it tends to get more slower over a period of time? What is the reason?
Sir,
Over
can I
time,
answer?
what can happen is that over time, what happens is that your computer starts to store. Um, so basically, as you would have mentioned, your computer needs data in order to process. So what happens is that over time, it begins to store up data that it doesn't need anymore. So that could be one of the situations why it begins to run slow because it needs to clear off those old data that it's not using anymore. Sometimes some old data might be going into the memory all of the time and it's taking up unnecessary space inside of the memory. So as I would have mentioned, the memory is when the computer is using to access to process the information. So if it is filled up, then your computer is going to move slow because new information can't go in, and then you got to move information in order for to make space inside of the memory. So, and then even on your hard drive, old unnecessary data might be on your hard drive, and that is why it might be running your computer a little slow. That is why in those cases, if your computer is old, what they might recommend is that you do a clean installation of the operating system. So what happens there is that it wipes all of the old data and it puts on the new data so that everything is fresh and clean like a new system, so that it should run a little smoother.
Sir, one
Okay,
question.
sir. Thanks.
Sir, I just hearing this name and I just want to ask you. Sir, a graphics card, sir, right? What is it really? And can you put one on a laptop?
So a graphics card is something like the CPU inside of your computer. But the graphics card is only designed for one purpose, and that is for graphics, or basically video. So that's why it's also called a video card. I think we should be discussing that sometime soon, I'm not sure. But it basically it's created to process video only, so that it takes some of the workload off of the CPU. Um, Laptops have their GPU or their graphics card built into the CPU. So that is why you when you play a game on a laptop, it might not um, run as smooth like if you're playing it on a desktop, which has a graphics card, because then you have like another device to process that video, and you have less stress on your CPU. And yes, some laptops do support graphics card, but you have to plug it in externally, like if you plug it in a flash drive.
Okay, sir.
Any other question on today's topic? Today we looked
No, sir.
at today we looked at what is memory. Remember the three terms. There's primary memory, main memory, and memory. They refer to basically the same thing. Um, we looked at the three types of memory: RAM and ROM. So which one is volatile and which one is non-volatile?
Sir, another thing, right? Before I left you on this one. Sir, a graphics
Sajid,
card, right?
Sajid just asked
Is
a
it?
question.
Yes, sir. Sir, someone just literally, I had to argue this game. Sir, a graphics card, is it
Yes. So I just asked the question to the class. Which one of these memory is volatile and which is non-volatile? If you guys can remember, RAM or ROM? Which is which? Anyone?
So RAM is volatile.
Good. Which one is non-volatile?
ROM.
ROM?
And what is the difference between volatile, non-volatile? Or what does it mean? What does it mean to be volatile? What does it mean to be non-volatile?
Sir, when it's volatile, the data disappears when the computer powers off or malfunctions. And when it's involatile, the data can be accessed. The data is saved without power.
Very good. So that's another thing too. If you if you have a desktop and say for example you are working on say you got a Word document open and you're typing out an assignment and then blackout come. When you turn on back the computer, do you expect to see that assignment?
No, sir.
No, sir.
No, you won't see it. That is
Sir,
because,
sir,
yes, Kila?
I don't know, but on my laptop, if I'm typing an assignment or whatever, and then the power goes out, when I come back to it, it's still there.
Well, on laptop, remember they have a battery,
Unless it, mm,
and sometimes what happens is that the
what does it
laptop,
go? The computer battery dies
uh-huh.
and the computer shuts off completely. When I come back in, my work is still there.
Well, that's another thing about laptop. Laptop, they have like a built-in technology in them that just before it notices that the laptop is gonna die, it actually saves everything on the computer and goes into like a sleep mode. So it doesn't actually die, but it goes into like a sleep mode. So when you charge it back up and you turn it on, you see all of the information.
Okay, sir. Thank you.
So that's why on mainly desktop, when you lose the power, so this all goes back to memory and CPU. All of your data is stored inside of the memory. Even the Word document you're processing is inside of memory. So when you lose that power for your desktop during a blackout or something, you won't be able to see back that assignment because the memory, the RAM, lost its power, so you can't store the information anymore. But as I mentioned for the laptop, they have battery inside of it. They have like technology that will allow to save that information just before it completely dies. But that's why you have to charge it up quickly before. That's why it's not recommended for a laptop to drain the battery completely so that that information can still be there when you're starting up the computer. All right. If there's no other questions, you guys can go to your next class, even though that might be a while from now.
Okay, sir.
Okay, sir.
Sir, yes, sir. Like I was saying, the graphics card, right? Is it like a card or something like this thing, like with a whole set of fun on it?
Both. It comes in different form, different size, different shape, so there's no specific design to it.
Cause somebody just keep arguing on me because they're saying it's a card, but I telling them it's something else. Alright, I'm gonna tell them, Thank you, sir.
So it can be a card without fun. So basically, if it's a low end graphics card, it doesn't need a fan. You can run without one. But if it's a high end
Also, there's
graphics card,
also there's two type, low end and high type graphics card.
not really a type, just that just as how you have CPU that are slower and some that are faster, graphics card are the same.
Okay, sir. Alright.